Greetings, Sky Watchers, and welcome to the sky above us. I'm James Albury, and I'm your tour guide to the night sky. In Star Wars Episode 4, our favorite bounty hunter, Han Solo, makes an interesting statement regarding his ship, the Millennium Falcon. What am I talking about? Let me show you. Almost 50 years ago, in a galaxy not so far away, there was a minor dialogue faux pas that irritated astronomers and other science communicators for decades. Only through creative retcon work was this intergalactic blunder able to be redeemed in the eyes of the astronomical community. In other words, this is a story of how it all got fixed. So, if you've seen Star Wars Episode 4, A New Hope, you might remember the scene in the Mos Eisley Cantina where Han Solo is bragging about how fast the Millennium Falcon is and that he made the Kessel run in only 12 parsecs. The Kessel run was an often traveled route between the planet Kessel and the planet Savareen. The reason Han Solo had to make the trip so quickly was that he was carrying raw coaxium, a very volatile and highly explosive substance, often used in hyperdrive reaction chambers, but also used as fuel. The problem is, once mined, unless it's stored in a temperature-controlled environment, coaxium gradually destabilizes, turning red in color and explodes violently. Therefore, it was very important for Han to get the coaxium to the refining facility on Savareen as quickly as possible. Now, given that line of reasoning, initially you would think, oh, a parsec is a unit of speed. Well, in actuality, it's a unit of distance. Because space is so big and the stars are so far away from us, it's not practical for us astronomers to use miles or kilometers when measuring distances in space. Since light travels at almost 300,000 kilometers per second, the light year became a standard unit of measure. The International Astronomical Union officially defines a light year as the distance the light travels in a vacuum in 365.25 Earth days. Therefore, in 1 year, light travels almost 9.5 trillion kilometers, or almost 6 trillion miles. So, what is a parsec, you ask? Let me show you. For a long time, people thought Earth was at the center of the universe. One reason most people made that assumption is because we can't feel Earth moving. One argument made against Earth orbiting the Sun was that if we were moving, we should see the stars changing position with respect to each other as our position changed. This is called parallax, and you experience it every day. When you're riding in a car, objects close to you move more in your field of view than the objects further away. A fun test of parallax is to extend your thumb and hold it at arm's length. If you close your left eye and keep your right eye open, use your right eye to look at your thumb while positioning your thumb in front of an object in the distance. When you switch eyes, opening your left eye and closing your right eye, you will see your thumb appear to change its position with respect to the object you are obscuring. This is a demonstration of parallax, and that's what makes 3D vision possible. It's that little shift in viewing position that gives objects that appearance of depth. How does this correlate with distances in space? Well, to find the distance to the nearest star, we had to use some math. Trigonometry is a branch of mathematics that involves angles and length ratios. Mathematicians found that if you knew the length of one side of a triangle and measured the angle opposite that side, you could determine the distance along an adjacent side of that triangle and the focal point of that triangle. I know, it sounds a little complicated, but we'll demonstrate this using the stars, and it'll make more sense when we're done. Let's take a picture of the night sky on June 1st. We'll focus on one star and record its position with respect to its celestial neighbors in the background. Then we'll take a second picture of the same part of the sky 6 months later on December 1st. We'll then study the pictures carefully to see if we detect any movement in the stars, specifically the star we were focusing on. Whatever angular distance we measure, we have to divide that in half to calculate our final result. That's because we're working with two triangles. The Sun is at one corner of the triangle, the Earth is at the second corner, and the star we're focusing on is at the third corner. Therefore, if in 6 months the nearby star moved 2 seconds of arc with respect to its neighbors, that star is said to be 1 parsec away. Parsec stands for parallax second. Briefly put, there are 3,600 arc seconds in 1 degree of arc, and there are 60 arc minutes in 1 degree of arc. By comparison, the moon is half a degree or 30 arc minutes in width. That means the moon is 1,800 arc seconds in width. So by comparison, 1 arc second is a very small unit of angular measure. Here's where the trigonometry comes in. Since this triangle is so skinny, we don't have to use trigonometric functions like sine or cosine in determining the distance. We just use the formula of 1 divided by the measured parallax angle in arc seconds. We know the radius of Earth's orbit, 1 astronomical unit, and in order for a star to make a parallax angle of 1 second of arc, that star has to be 206,265 astronomical units away. If we convert astronomical units into light years, where 1 light year equals 63,241.1 astronomical units, 1 parsec equals 3.26 light years. Therefore, since Han Solo made the Kessel run in 12 parsecs, he traveled a distance of slightly over 39 light years. And that's quite a trip. Now, not to spoil how Han actually does this, but normally the Kessel run is 20 parsecs in length. He basically did it in 12 parsecs because he took a shortcut through a protoplanetary nebula. It wasn't the safest choice, but it was effective. To watch how he does this, check out the movie Solo, a Star Wars story, streaming on Disney+. All right, my friends, next time you watch Star Wars, contemplate how far Han Solo traveled during the Kessel run. It'll blow your mind. Before you go, visit our website, theskyaboveus.org. From there, you can watch previous episodes, listen to the Sky Above Us podcast, get the Sky Above Us merchandise, and you can even ask me an astronomical question that I'll answer in a future episode. In space, the units you use are very important, especially if you remember to keep looking up.